Hello everyone. In this video I'm going to actually discuss the continuous function, and basically when we call a function is to be a continuous function. Let's assume we have a function like f of x. This function is said to be continuous at x equal to a if the limit of f of x when x approaching to a is equal to f of a. And from there, a function is said to be continuous in the interval of a to b if it is continuous at each point in that specific interval. And from this definition, we can say both f of a and the limit of f of x when x is approaching to a should exist in order to have that specific function to be continuous. So from this definition, let's look at two examples. For the first example, we want to find a such that the following function to be continuous. So we have two terms inside this function, as you can see. When x is not equal to 0, we have sine of 2x over x squared plus x. And when x is equal to 0, f of x is equal to a. And if we actually recall the definition of the continuous function, it says the limit of f of x when x is approaching to, let's say here, to b, for example, should be equal to f of b. And from here, f of b is actually 0 for this specific function, and the limit can happen for the function of sine 2x over x squared plus x. So what I can write, f of actually 0 from the function is a. Now we have to look at the limit, and for the limit I have to look at the top function, which is equal to sine of 2x over x squared plus x when x is approaching to 0, and this is going to be equal to a, and this is based on the definition of a continuous function. So if we plug in 0 inside this function, the limit is going to be an indeterminate form in the form of basically 0 over 0. And in order to solve this limit, we have to use some sort of algebraic simplification. So in order to do that, what I'm going to do is to multiply both top and bottom part with 1 over 2x. So it is going to make the limit of x approaching to 0 sine 2x over 1, and this is going to be multiplied with 1 over 2x over, and what we have for the bottom is going to be x squared plus x over 1 times 1 over 2x. Yeah, so if you look at the top part, what we have is sine of 2x over 2x, which recalls the limit of sine of theta over theta when theta is approaching to 0, which is going to be equal to 1. So the top part will generate 1. So what we can write from this term, we can rewrite this limit in the form of the limit of 1 over x squared plus x over 2x when x is approaching to 0. Now we can actually we can do factorizing, so we can make it in the form of the limit of 1 over factoring x. It is going to be x plus 1 over 2x. This can be cancelled. So now it's time to plug in 0 there. So this limit is going to be 1 over 1 over 2, and the final answer is going to be 2. So the answer of this limit is 2, which means this is 2 at the end, and from there we can say a is actually equal to 2. So what we did, we just looked at the definition of a continuous function. First, we looked at the value of that function at the specific value of 0 basically, and then we took the limit of the function based on the other subfunction that we have, and we found the limit, and from the obtained limit we could find the value of a. Let's look at another example. In this example we have basically a function, as you can see in here, which contains two terms, a plus sine squared x for the interval of 0 to pi over 4, and the other term is a square root of 2 times cos 3x for when actually the interval is pi over 4 to 2 pi. So we want to have this function to be a continuous function for the interval of 0 to 2 pi. So in order to actually investigate this basically continuous function here, we have to look at the point in which we have the possibility of discontinuity. So, and that basically value is pi over 4. And if we look at this interval, it shows that basically pi over 4 can be plugged in top part, so we can find the value of f of pi over 4 in that specific point, actually pi over 4 in the top function. So it's going to be a plus sine squared pi over 4. We know that sine of pi over 4 is a square root of 2 over 2, so it's going to be a plus a square root of 2 over 2 squared, and this is going to make a plus 1 over 2. Okay, and for the other component we have a square root of 2 cos 3x, and now we have to look at the limit. So it's going to be the limit of basically a square root of 2 cos 3 pi over 4, actually let's say cos 3x when x is approaching to pi over 4, and if we plug in pi over 4 in there, it's going to make the limit of a square root of 2 cos 3 pi over 4. Okay, so this is going to be, let's write it in this form, a square root of 2 cos 3 pi over 4, and this is going to be a square root of 2 times minus a square root of 2 over 2, and this is going to make minus 1. Okay, and based on the definition of continuous function, it is going to be a plus 1 over 2 equals to minus 1, and this is going to make a equals to minus 3 over 2. So if you look in here, pi over 4, we are actually approaching to the pi over 4 from the positive side, from the bigger side basically. So we have to consider that in here too. So it's not pi over 4 from the left side, it's pi over 4 from the right side. Okay, so what we did again, we used the definition of a continuous function here. First we looked at the value of the function at the specific value of pi over 4, and then we look at the limit, basically pi over 4, and from right side, and then we obtain the limit based on the subfunction that we have, and from there we could find the value of a, which was actually the main thing that we have to find for this problem. Thank you very much for watching this video. If you enjoyed, please subscribe our channel.